Then lastly, you're going to do the vector diagram. So let's see. Here, the free body diagram. Always going to have a gravitational force. When you put that plate in on the inclined plane, so this is the gravitational force. You decompose the gravitational force into parallel and perpendicular to the plate. So this is going to be the normal force, which is now different from gravitational force. That's different from gravitational force. Normal force is not equals to the gravitational force anymore. Therefore, friction force change. Friction force depends on the normal force, not the gravitational force. And you see that, let me see, if I were to write it, this triangle, right? If this is a right triangle, you have a gravitational force that's perpendicular. This is Fg. And then we have here, here. So this is another perpendicular. So you see that this angle here, that's going to be the same as this angle. That's because this triangle here is perpendicular, but this is also perpendicular. So you see that this angle, so that angle plus the orange, this one, that has to be equals to 90 degrees. And you also see, magnify here. Let's draw with a blue or something. So here, this and this here is perpendicular. So what you see, that's perpendicular. So this is perpendicular. So that's why this has to be equals to the same angle as this. When the object is a constant, so what we're going to do for this one is that you're going to put before that, okay. So the object is going to be in a, when the object is in a constant motion. So vector diagram, blah, 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 blah. You're going to do this, you're going to draw this vector diagram in your thing. What you're going to have is another force that's in this direction. That's going to be Fk, the friction force, or I should say friction force. And this friction force becomes mu Kn when the object is sliding with constant speed, right? Mu K equals this, and that's equals to Fg parallel. Because the only force that it's pushing down is this Fg parallel, and that has to be equals to the friction force for the object to be sliding with in a constant motion. So FG tangent theta is equals to FG parallel divided by FG perpendicular. And we know that FG parallel is equals to mu Kn. That's equals to the kinetic friction force. Tangent theta FG perpendicular. And let me see, FG parallel, that's the push force down. That should be equals to the friction force, kinetic, when it's at the constant motion, mu Kn. And what we also know is that FG perpendicular, that should be also equals to the normal force. So you see from here, mu Kn divided by n, this should be mu K. And this should be the mu K u. So compare this mu K with this mu K you found earlier, because it's still the same. I'm using the same plate. Let's see. So here is the incline video intro.
Next is to leave this wooden plate on top of this, but I'm going to start tilting. And at critical angle, it starts sliding. But that's not what we want to see, because at the critical angle,
so it's at the critical angle, the friction, the object starts sliding. But that's not the angle, right, that we want to look at. What we want is the object is a constant speed. We want to have object is at constant speed. At the critical angle, do you think the object is going to be sliding constant motion? No, critical angle is the maximum static friction force, right? So that's a little bit higher than kinetic friction force. Therefore, at that angle, the object won't be sliding with a constant motion. What you got to do is to make it start moving, push it a little bit, and then lower to find the value that it slides with the constant speed. So see.
it starts sliding, and that's a little bit above the maximum static friction is higher than the kinetic friction. So what we got to do is to measure kinetic friction, is that I have to make it a little bit higher and then adjust the angle to make it to be a constant motion. Not when it starts sliding, but after it slides it, I have to change the angle. That it's a constant motion. So let's see it.
So, okay, so you do this, and then next video, I'm going to be showing the angle.
It's approximately about this angle.
So you see that angle is the angle that is the object slides with the constant motion, and then you put it into your calculator, or you can even Google it to find the tangent of 14 degrees. Is your value the same as the mu K you calculated earlier? Because it's still what you're looking at is the same object. It's the same materials that's in contact, wooden side and then a plate. So would you expect to see the different value or the same value? Are they within the error? If there's any error, discuss where the error is coming, or if it's not the same, why it shouldn't be the same. So that's the end of this lab, and I hope you understand and have fun with this lab. All right.